like I said earlier, this is kind of one of my favorite lessons to teach. I don't know why. Just is. It says completing the square. We're going to talk about that in a second, but we got a problem to do first before we do completing the square. So they throw in this example, and you guys ever heard of the quadratic formula? Yeah, you probably did that. Did you do that in Algebra 1?
I did some of it like we hardly did. We did the
Negative b plus or minus square root of b squared minus 4ac over 2a. Yeah, that's something that a lot of people in Algebra 1 would learn. Not everybody, but some people would. But what we're going to do, in order to come up with that formula, and that's what we're going to do tomorrow, hopefully if we finish this lesson today, tomorrow we're going to actually come up with the quadratic formula. Usually in Algebra 1, they just throw it out there. They say, here it is. It's kind of like a lot of geometry teachers with Pythagorean theorem. They just throw it out there. They say, here's how you use it. But we kind of came up with a way to do it. Anyway, that's what we're going to do. You got to be able to complete the square in order to come up with the quadratic formula. And I think it's important, especially for an honors class, to see where the quadratic formula came from. It wasn't just some crazy thing that just appears and somebody just threw a bunch of numbers against the wall and see what works. All right, there's a method to their madness, as they say. All right, so you got to know how to complete the square. So this one right here, you don't have to be able to complete the square. Now you could solve this by completing the square. And maybe we will go back to this. That doesn't look like in my notes we do, but we could go back to this, solve this by completing the square. But this is just regular old, this is nothing new. This is kind of review, I guess. To tell you the truth, I'm not really sure why they put this particular example in here, but we're going to do it anyway. All right, what if I ask you to solve for this? What's the first thing that pops in your head in order to solve for x here? You got a trinomial, right? That should look fairly familiar to you, right? All right, so what do we normally do when you have a trinomial like that? Usually factor, right? And this is one of our special type of factors. Look at the 16. I can take the square root of something to get 16, correct? Right? It's not like a 17. If it was a 17, I would just put my two sets of parentheses and try to factor. But it is a 16, so that should trigger something in my head, thinking, you know what? This could be one of those perfect squares. Okay, perfect what? Squares, okay? So you see where this problem's getting. This is going to kind of lead us into it a little bit. All right, so this is a perfect square. How do I know it's a perfect square? So what's being squared to give you x squared? What's being squared to give you 16? What about the middle term? Remember what we do? We take the a and the c, right? Multiply them together, which is 4x, and then do what? By 2, right? Double it, okay? Multiply it by 2. Does that give us that? It does. It gives us the 8x. So yes, and this is a minus. Well, it could be a plus 2, but this is a perfect square, all right? So watch. I could just look at it, realize it, all right? That's why we learn the perfect square, because you want to be able to look at something and say, oh yeah, that's one of the special type of factorings. This is kind of easy. So I put an x here. I put a minus. Always look for that sign and put a minus, because this is always going to be positive. This could be plus or minus, okay? This one's always going to be positive. And what's being squared to give you this? 4, all right? Again, how do I know that's a perfect square? Because I take these two ones on the end, multiply them together, 4x, double it, that's 8x, I'm good. So I know that's a perfect square. That's old stuff. We just learned that not that long ago, a couple lessons ago, I think, okay? And that's equal to what? 49. Everybody with me so far? It's just a regular factoring. Now we got to solve for x. So what do we do to solve for x? What do you think the first thing? Do I want to get rid of that minus 4 first? Nah. What's happening to that whole x minus 4? It's being what? It's being squared. How do I get rid of something that's being squared? Square root it, okay? Now, I could put a big old square root right there, but I'm not going to, because you know what that square root's going to do to that square. What's it going to do? It's going to cancel it out. So I'm not even going to, it's just too much to put on there, okay? So what is the left side now? X minus 4, because I took the square root of the left side. I also have to do what? Take the square root of The right side. Now, do you remember what I always put in front of it? Plus or minus. Good. All right? And we can do this in our head. What's the square root of 49? It's 7, but you got what in front of it? Plus or minus 7. So this really are two things right here. I'll tell you what, let's do this before we talk about that. Add a 4 to both sides, right? Add a 4. Everybody got that? So x equals, look what we got. We got positive 7 plus 4, and we have what? Negative 7 plus 4, because this is plus or minus. So we got two answers here. By the way, always look to see what your highest exponent is. That's how many answers you're going to have. All right, this is x squared, means you're going to have two answers. If it was just an x, you're just going to have one answer because it's x to the first. That's a cool little trick, right? All right, so watch this. So x equals what? 11, and x equals negative 3. So that is your answer for that. What we're looking at is this perfect square. That's the key to what we're going to do in this whole completing the square thing. We're going to take something that may not be a perfect square, but we're going to make it. We're going to force it into being a perfect square. Once we get it to this situation right here, then the rest is super easy. Okay, this right there, that's what we want to get it to. All right, we're going to see another problem. And that problem isn't going to be so easy. It's not going to be a perfect square when you first see it. But we're going to manipulate it. We're going to do some stuff to it in order to make it a perfect square. You can always solve for x by completing the square. You can't always do it by factoring. Sometimes this doesn't factor. Okay? Not every trinomial factors. You realize that? So sometimes you can't factor it to get an answer. So you need another way. And completing the square works every time when you have a trinomial. Okay? All right. So let me lead you up to something first with that perfect square stuff. What I'm trying to do right here is just to establish a pattern with perfect squares. I'm just going to use the plus version. I could use the minus version as well, but I'm just trying to make this easy. All right. So what is this? X plus 2 quantity squared. Let's do it in our head. You could write the two sets of parentheses, then do the FOIL. You could do that, but I think we should be able to do this in our head now. So what are we doing? It's x plus 2 times x plus 2, correct? And this is a perfect square. Would you agree? Because you've got something in a parentheses with a squared on the outside. That means it's a perfect square. So what's that going to be? It's going to be x squared. What's the last one going to be? Remember, first, outside, inside, last, right? What's the last going to be? Plus what? Plus 4. Okay? What's the middle going to be? Remember that? You take the two ends, you multiply it together, which is 2x, and then you do what to it? You double it. So what's the middle going to be? 4x. All right? If you wanted to put your two sets of parentheses, then do FOIL, you could do that. But at this point, we should be able to do that in our head. Can you do that in your head? Should be able to. Let's do another one. After we do a few of these, everybody should be able to do this in their head. What's this going to be? X squared. What's the last one going to be? Plus what? Plus 9. What's the middle one going to be? What is it? What? What did we say we did here? Do the same thing you did here.
6x.
It'd be 6x. It'd be 6x. Because it's 3x, then you double it. Right? That's how you find the middle one. You got it? Let's do a couple more. Just to establish a pattern. I'm going to show you the pattern that we're looking for in a second. So what's this going to be? X squared. What's the last one going to be? Plus 16. What's the middle one going to be? 8x. Now you're getting the hang of it. Okay, let's do one more just for fun. So x plus 5. So it's going to be x squared. The last one, 25. The middle one, plus 10x. Everybody with me? Okay. Now, we see where we got these from. What we're going to do is this. Now, remember these numbers right here. Can you remember those numbers? Okay, what I'm going to do is I'm going to get rid of them. Yes. What I want to do, I shouldn't have got rid of the pluses. Let's just do that again. I don't know. If I would have just drawn them, probably been just as quick. Let's get rid of that. There we go, plus. What I want to do is I want to figure out, not looking at this, pretend we don't know that stuff. In fact, I think I did this in my pre-calc class. Let's take this. Okay, watch. Pretend we didn't know that. All right, so I'm going to cover it up. So what I want you to do, now you saw it, you know what it is, all right, but I want us to pretend that we didn't know what it was, and how in the world are we going to find what that perfect square is? So what I want to do, oh, you know what I should have done? It's dumb. What did I say this was going to be? This was 4, this was 9, this was 16, this was 25. Okay, sorry about that. I got a little ahead of myself. Watch. What I want you to do, listen, what I want you to do is I want you to see a pattern to get from the middle one to this one on the end. What'd you do to this to get to that?
You divide it by 2 and then take the square.
Take the square?
Square.
Square it, right. That's a better way to say it. Good. You found it pretty quick.
I'm so smart.
You are. You're very smart. All right. So let's take a look. Everybody look. Shh. So what'd you do to that 4 to get to 4? Now, if I didn't have all these written down, if I said, what'd you do to 4 to get to 4? What would you tell me? You just kept it the same, right? But did we keep all these the same? No. But there is a pattern, all right? And you saw the pattern pretty quick. So what did you do to 4 to get to 4? What'd you do to 6? The same thing. What'd you do to 6 to get to 9? 8 to 16, 10 to 25. You took the 4, what'd you do to it? Took half of it, divided by 2, right? And then you squared it. So what's 4 over 2? 2. 2 squared is 4. What'd you do to that 6? You divided it by 2 and then squared it. I'm getting somewhere with this, okay? The stuff that I'm doing right now, you're going to be doing, okay? So hopefully you're paying attention. So 6 divided by 2 is 3. Squared is 9. We'll keep doing this. We only got a couple more to do. Squared. 8 divided by 2 is 4. Squared is 16. One more. 10 divided by 2 is 5. Squared is 25. So you see what you got going from here to here. What if I did this? What if I said x squared plus 12x plus blank? So what's going to go right here? 36. Everybody see it? I mean, I'm making this easy because it's like the very next one. All right, but you could do that with anything. What if it was really weird? Watch. And by the way, what is the perfect square? Once you get to this, how would you write it as a perfect square? Is x what? Plus 6. You see that? Watch this. I think this is kind of easy and some of you guys aren't paying attention. I see eyes kind of wandering. You need to focus on this, okay? What if I had something like this? X squared plus 7x plus blank. So what's going to go right here in order to make this into a perfect square? Well, we're not going to use decimals. We're using fractions. No, be happy. Okay, fractions are way better than decimals in this situation. Okay, so 7 over 2, and then do what? What do we do? Square it. Okay, and what is that? 49 over 4. All right, so what goes here? 49 over 4. So what's this? If I ask you to factor that, that's actually a perfect square because I can take the square root of this, can't I? Right? Is something being squared to give you 49 over 4? Yeah. That's 7 over 2. That's what we squared, isn't it? So what's this going to be? X plus what? 7 over 2. You could get that number right there 2 different ways. You could just look at the middle one and say, oh, it's the middle one divided by 2. Or you could look at the last one and say, what? It's the square root of it. Square root of 49 is 7. Square root of 4 is 2. Either way, that's what your number's going to be right there. With me on this? All right. What we did right there was super important. Now we're going to put it all together. All right. So let's do this. I didn't do this in my notes, but I'm going to do this right here. Let's do it in a different color so it doesn't go yellow. You can see that. So let's do this. X squared minus 8x plus 16 equals 49. Yeah, let's do it this way. This is probably not the best example, but I really don't like the example that they give you. No, that's all right. Let's go right to that example. Forget that, okay? I do like the example that they gave us. I skipped example 2. We kind of did one like example 2. It wasn't exactly, but just for the sake of time, I want to get to this. So this is example 3, and it says to solve. And we're going to solve it by completing the square. And you're going to find out that you don't have any other recourse. There's no way at this point that you're going to be able to solve for this by factoring, because it doesn't factor. Okay. So what if I wanted to write this as a quadratic equation? All right, so put everything on the left-hand side, set it equal to 0. What would that look like? X squared plus 10x, what? Minus 15 equals 0. So I wrote it like that for a reason. I want us to look at this and see if I can factor this. All right, on that first problem that we did today, yeah, you looked at it, it was a perfect square. It's not always going to be a perfect square in solving problems, but that one worked out nice. Is this a perfect square? No, because nothing's square to give you 15. Can I factor it? No, because if I put my 2 parentheses there, what times what is negative 15? And those same 2 numbers add up to 10. Is there anything? Is there anything? Maybe. Is there anything that equals 15 or negative 15 that also adds up to 10? Can you think of something? No, because you got 1 and 15. Is there any way to get a 10 out of a 1 and a negative 15, or a negative 1 and a 15? No. What's your only other possibility? 3 and 5. Is there any way I can manipulate 3 and 5 to add or subtract to get a 10 out of it? No. So will this factor? No, it will not factor. Okay, so we need another method. So what we're going to do is this. A lot of times, they'll set it up as a quadratic equation, set it equal to 0. So here's what we're going to do. It's just, that's nothing over there, okay? So what I want to do is I want to move this. This is not a perfect square, so I want to move this to the other side. It's going to look like what we just did, but I'm going to put a little extra thing in there. Plus, and I'm going to leave a blank. Books don't usually do this, but I like to put the little blank right there. I think it's good to see, equals 15. Now, watch very carefully. I want to make this. Remember I said earlier I'm going to force this to be a perfect square? This is where I do that. So everybody's paying attention, right? Because this is it. This is the crux of this problem. I want to make this into a perfect square so that I can solve it like I did that first example. All right? It's not a perfect square the way it is, but I'm going to make it into a perfect square. I'm going to force it to be a perfect square. How do I do that? How do I make this so I can put 2 parentheses and a squared on the outside? I take 10 and I do what to it? Divide it by 2, and then I square it. 10 divided by 2 is 5. 5 squared is 25. So I'm going to put a 25 right there. I made that into a perfect square. Would you agree? Now, it is an equation, though. So I can't just arbitrarily add a 25 to one side. What do I also have to do? Add a 25 to the other side. Very good. So that's legal, isn't it? It's balanced now, okay? One side and the other side. That's a really important step. The rest of it, it's kind of easy now. So I made that into a perfect square. That's forced into a perfect square. So what is it now? It's x plus what? 5. Everybody see that? So I made it into a perfect square. Equals, what's that? 40. Now, doesn't this look almost identical to example 1? Yeah, so now I can solve this just like I did on example 1. All right? That's why they call it completing the square. I completed this thing over here in order to make it into a perfect square. And that's a perfect square. So what's my first step? Square root both sides. So x plus 5 equals plus or minus square root of 40. One more step. We got to simplify square root of 40. We'll do that at the end though, okay? So what do I do now? X equals, get rid of that. I could put it at the end, or I could put it at the beginning. Let's put it at the beginning. So negative 5 plus or minus the square root of 40. But we're not going to leave our answer like this because I can simplify the square root of 40. Always, always keep your answer in simplest form. So we got x by itself. That's good. So we solve for x. We just got to simplify the answer though. All right, so x equals negative 5, watch, plus, I tell you what, let's do this. Let's come over here off to the side and simplify the square root of 40. What am I going to do? I would go 4 times 10 for sure, because I know the square root of 4, I can get a whole number out of it. So what is this? Square root of 4 is 2. What do I do with square root of 10? Just keep it to square root of 10. So that's the square root of 40 simplified. So what do I got? Negative 5. You could just keep it like this, tell you the truth. How did I write it? Yep. You could just go plus or minus. What's the square root of 40? 2 square root of 10. That's the easiest way to write the answer, the most compact way to write it, putting the plus or minus. Some people might write x equals negative 5 plus 2 square root of 10. And what else? X equals negative 5. What else? Minus square root, or 2 square root of 10. And you could do that if you wanted to. All right? Isn't it a lot better or easier, compact, writing it like that? Yeah. So that's the way you'll probably see the answer written in the book. That's the way I would write it if it was me. There you go. You solved for your first quadratic equation, and you solved it by completing the square. You can do any quadratic equation. It's a trinomial, x squared x and a number, okay? You can do any of them this method. All right, let's do another one. This one's a little bit more complicated, but you figured it would be, didn't you? Yeah, you didn't think they would just stop right there, did you? So here it is. Here's another one. This is example 4. This time, you got a number out in front. Doesn't that always create trouble? Yeah, and it does here too, but not that much trouble. But this isn't going to be near as pretty as what we did before. You could sit here and try to factor it if you wanted to. I wouldn't, okay? Between the two methods that we got right now, between factoring, and I don't even know if it does factor. It actually would, but it's too much trouble to factor. Let's just complete the square, all right? I think it's a better method. So first of all, I don't like that 3 in front of there. So how am I going to get rid of it? Divide everything by 3. You got it. Divide this by 3. Divide that by 3. Now that's going to be a little ugly. That's going to be a little ugly. And even divide the 0 by 3. But what's that going to be? 0 divided by 3. It's just going to be 0 anyway. But I'll put it in there just so you know. Everybody with me? All right. What do we got? That cancels. So I've got x squared minus what? Let's put 13 over 3. Let's leave it as a coefficient and put the x right here. You okay with that? Now, this is not a perfect square, is it? So what am I going to do with that? Put it where? To the right side. And what am I going to put here? Put a plus and a blank, because I'm going to complete the square. I'm going to put something in here that makes this into a perfect square. So if I chuck this to the right side, what am I going to get? Just 10 over 3, because that was a 0, right? 0 plus 10 over 3 is just 10 over 3. Okay? That wasn't so hard so far, was it? All right, that's just getting us ready. Just setting the table. Now we're actually going to sit down and eat. Okay, we're going to do it. All right, we're going to figure out what goes here. How do I know what goes right here in this blank? I take that middle coefficient, that 13 over 3, and what do I do to it? Divide it by 2. But since it's a fraction, I'm not going to divide it by 2. I'm going to multiply it by a half. Isn't that the same thing? Okay? Everybody see that? And then I'm going to take that and do what to it? I'm going to square it. So let's simplify this. What do I got? 13 over 6 squared is, let's see, what's that? 169 over what? 36. So that's what's going to go right here. I know it's ugly, but it is a perfect square, isn't it? All right, so I got 169 over 36. And then if I do that to the left side, I do that to the right side. Okay? Now, the left side, it looks complicated, but we actually made it pretty easy because we made it into a perfect square. So what's going to go inside this parentheses? An x. Always look to that sign right there because that's always going to be positive. That could change. So what's going to be my middle one? Minus. Now, what goes here? It's just 13 over 6. Right, remember, it's either half of the middle one or the square root of the third one. Okay, and that's 13 over 6. So that is this factored, all right, because it's a perfect square. What do we do here? Just find a common denominator. 3 times what? 12. So that times 12. And so let's just keep doing it off to the side here. So what do we got? 120 plus 169 over 36. What's that? 289? Yep, 289 over 36. We good? All right. So now we're at where we were on example 1, right? This is what example 1 would have looked like if it was a little bit more complicated, but we know what to do now. Now I got to get rid of the squared. Okay, how do I do that? Square root it, right? So I got x minus 13 over 6 equals plus or minus square root of, 289 over 36. Let's do this. Let's add that 13 over 6. So what's x equal to? 13 over 6 plus or minus square root of 289. That looks familiar. Maybe not to you, but it does factor, or it does, the square root comes out nice. It's a 17. Did you know that? So 17 times 17 is 289. All right, over what? 6, because I got to take the square to the top and bottom. All right. Now let's separate. And we definitely need to separate them now. Okay, I said before that we didn't. On that other one, we really didn't have to. But these, you can simplify both of them. So what do we got? I got 13 over 6 plus 17 over 6. And I also have, what? 13 over 6, what? Minus 17 over 6. 13 plus 17 is 30 over 6 is 30 over 6. It's 5. So that's one answer. What's this? 13 minus 17, negative 4 over 6. Reduce it. X is negative 2/3. And that is your answer. Man, I wish we had like 5 more minutes. I'm going to write the problem down, and it's in the book. This is example 5. Don't pack up. You got time after the bell rings. You guys just stand around in the hallway, talk to each other anyway. 5x squared minus 10x plus 9 equals 0. Can we do this in 2 minutes? Let's try it. Divide everything by 5. So let's go fast. So write fast, or you could just watch the video. I'm just going to keep that 0. Is that all right? Even though I do divide by 0, or divide by 5, I'm sorry. So what do we got? X squared minus what? 2x plus blank equals, let's move this to the other side, negative 9/5. Half of this is 1. Square it is 1. All right? Add a 1 to that side, add a 1 to this side. Now we made that into a perfect square. This is going to be x minus 1, and this is going to be 5 over 5, correct? So that's negative 4 over 5. This is where it gets a little weird. This is why we did that imaginary number stuff before we did this. Square root both sides, and then add a 1. At this point, you could probably do both of these things in the same step, couldn't you? You know you're going to add a 1 to both sides. What's this going to be? Plus or minus square root of negative 4/5. This is where it gets ugly. X equals 1 plus or minus. Let's break this down. What's the square root of negative 4? Is it? 2i. Thank you. It's 2i because you got the negative inside of there. Okay, so it's a 2i. And then, well, let's just do that. It's 2i over what? The square root of 5. Did I teach you this yet? I don't know if I did. Rationalizing the denominator. Remember, you can't. Did I talk? Okay, good. So I can't have that, so I multiply by square root of 5 times square root of 5. We're almost done. Hang on. Look, I did it in, 2.5 minutes. Equals 1 plus or minus. What's this going to be? 2 square root of 5 over 5, and then an I. Well, this whole fraction is being multiplied by that I. Okay? And then that is your answer. That's what x is equal to. There you go. So it's 5/6a, and you're doing a 1 to 18. You're doing them all. All right, there it is.